Okay, welcome to energy management. That is a demand side management lecture. Till date, we have studied what is the objectives and need of energy management, and what are the different methods are available, or what are the different options are there to do the energy management. First, we have studied the tariff. What are the options or what are the indications tools are available in the electric tariff itself to conserve the energy, to do the energy management and demand side management. We have seen the power factor improvement and advantage of power factor improvement, both technical as well as the economical advantage. We come to know the objectives of demand side management, and in demand side management it consists of two major part. One is the demand response, and second is the energy efficiency. So demand side, in demand side management, the utility should provide some financial incentive as well as the consumer education, so that the consumers encourage, it is the consumers are encouraged to use less energy during the peak hours, and use energy off peak period, or they should, or the consumer should move their demand during from peak hours to the off peak period. So the things we have already discussed everywhere, and we found that finally the both participation of consumer and utility will do the fruitful result from the demand side management. At the same time, the demand side management, there are methods, are the direct load control, which is in the hand of utility. They are going utility is directly controlling the load from the supply side, and whereas from the local side, that is the consumers, the consumer can do the load control by peak sleeping, valley filling, then energy conservation, load flexible load shape, then energy conservation, voluntarily retirement. All these things are, it can be carried out by the consumer itself. Okay, so this is the things, and we have also studies this PPT, that is the peak sleeping symbolic representation, the peak sleeping, valley filling, then conservation, flexible load shape, load shifting, and load buildings. Implementation can be carried out definitely from the market transformation. This is the best way to do from the market itself. Nobody is going to sell non-energy efficient electrical gadgets, transformer, motors, pump, refrigerator, ACs, and all these things. Or there should be some energy efficiency labelings are there. Without labeling, the product should not come into the market. So there is a ban selling as well as the production of such material. So definitely such type of activity will help in the implementation of demand side management. And whatever the program to implement the demand side management, it is the customer oriented, because there are different category of customer. They have the consumers has a different paying capacity, the utility time is different, utilization purpose of utilization is different. So there are different type of consumers are there, and it is definitely can categorize in the different uh, uh, on the different way, on the basis of usage as well as the application of energy. Now there is one more is the public private sectors are there. Government should provide some soft loan, government should provide some financial assistance for implementation of the demand side management, for the doing energy conservation, for purchasing the energy efficient machineries, manufacturing process, as well as the import duty. When the somebody is going to purchase technology, or somebody is going to purchase energy efficient machineries for the production purpose as well as the generation purpose. So this is the things which we have already considered uh, up to the last lecture. Okay, now we will consider the demand side management implementation issues and barrier. No doubt, all the things which we have considered theoretically, it is get implemented, because some of are very difficult. Some has technical problems based on the application, based on the places, based on the type of consumers are there. Okay, so what are the barriers and what are the issues uh, are there in the implementation of demand side management. So today we will discuss somewhat in detail. So first is the lack of information. So this is the very common things are there. Number of consumers or especially small scale industries or say power looms are there, even say small say what we can say that very small industries are there, or some manufacturing units or some servicing units. They are not bother about the electricity bills, or the not bother about electricity bill. Instead of saying that one, we can say that they are not educated related to the different zone of energy consumption. What would be the way to reduce our electricity by bill by shifting the load, or time of use are there. Similarly, what is the block rate tariff, what would be the rate at a higher energy consumptions, what would be the method to improve the power factors. Okay, what are the different losses may take place because of the old machineries, and best wrong practices in the production purposes are there. So such type of informations are not there, such type of educations are not there. We can consider the agriculture sectors. uh, they are the agriculture sector, the farmers is only to think about the pumping of power only, sorry, pumping of water is only. But then the consumer is not bother about what is the power factor of pump, what is the efficiency of pump, what is the discharge rate. Okay, so all these things if we educate in the different sectors, like agriculture sector, we will take some seminars, some awareness camp, some sort of knowledge to the such type of consumers are there. Definitely we can improve the power factor, and ultimately it is going to decrease our kVA demand, reactive power flow over the transmission line, and this lead to the best maintenance practices in the electrical installation. I will give the example is that one time MSDCL engineer came to meet me and ask to prepare some uh, say capacitor ratings. That is what would be the capacitor ratings to be connected in the different type of consumer. He gave me some data for the different type of consumers, because the power factor is low during in that small scale industry. And when the MSDC engineer told or say explain the things, they are not ready, because they thinks okay, this is the rules and this is all things, we will provide you only the paper. And no, but in electrical we have to provide some proper capacitor ratings are there, in such a way that the reactive power will be small. So I design, I just calculate what would be the kVA rating of the capacitor to be connected in the different small scale industry, so that they will get say in such a way that the consumer gets some benefit of power factor, and the other side utility get some technical advantage. The reactive power deficit is going to reduce. There is a deficit of the reactive power in the daytime, whereas in the night time there is a surplus of the reactive powers are there. So because of such informations, such a small group discussions, some awareness camp, definitely will avoid such type of barrier. So the very big barrier is the lack of information to the consumers or to the customer. Second is the cost of energy efficient machineries. Definitely, the cost of energy efficient machineries are higher as compared to the ordinary machine. I will give the simple example. In our home, if uh, we have a fans are there, okay, the cost of fan, ceiling fan is hardly 1800 or 1900s are there, even for the branded company. Whereas it consumes around 65 watt, whereas the BLDC energy efficient 5-star rating fans are available. uh, it consumes only 28 35 watts are there, but the cost is around 3500 or it may be a 4000 rupees. So there is a large cost difference between the energy efficient machineries and the standard machineries are there. So this cost become one of the barrier in implementation of the demand side management. No doubt, with due respect of time, or say as 2 or 3 year, we will find that the energy efficient fan cost price go on decreases because of the large production, because of the people education awareness among the consumer to use only the energy efficient machineries are there. One more example is that when I conduct a energy conservation program in one company, that is a Hindustan Lever Limited in Khamgaon factory. Now it is a Unilevers are there. During that time, the CFL price, CFL lamp price is 700 and 500 rupees. So it considered as a only the luxurious one. It is not considered for the, because the cost is very high. Nowadays, we found that the cost of LED lamp and CFL lamp is hardly 125 rupees, even 100 rupees are there. So when the people are aware about the energy conservation, about the energy efficient machineries and energy efficient gadgets are there, the production got increases. So the cost per production unit decreases. That is the total cost of the production decreases, and hence it decrease the market and decrease the rate of electrical machineries are there, isn't it? Number of companies come into the manufacturing, so again there is a competition. So cost of energy efficient machines is definitely it is a one of the barrier. Second is the tariff. So we found that some of the tariff based on the connected load. Say for example, in agriculture sector, suppose it is like that, the electric bill per month is 3000 rupees when you are going to connect 5 HP motors or 5 HP pumps. If you are going to connect 10 HP pump, then the electric rate will be electric energy bill per month is a 5000 rupees. So the people what the consumer may do, he will or the consumer or the customer going to take the permission of 5 HP pumps, and in actual practice the consumer is using 10 HP pump. So there is a wastage of energy and there is a small revenue generation from the such type of consumer. So if such type of tariff is there, definitely it is become a barrier, it become a hurdle or issue in the implementation of demand side management. So the tariff should be a actual energy consumed by the consumer which is going to take place in the energy meter. So there should not be such tariff, fixed rate tariff or without energy meter tariffs, or some subsidies, higher subsidies for the uh, some sort of say consumers are there, isn't it? For example, BPL tariff is there where the energy rate is hardly 2 rupees 50 paisa and 3 rupees are there. So such type of consumer does not think over the energy conservation, saving of electricity. The people are using lavishly electrical energy, and therefore such type of tariff become a issue, become a barrier in the demand side implementation. So this is the way. Uh, so our tariff should be designed in such a way that the tariff it should become a good tool for the demand side management. For example, block rate tariff, two-part tariff, that is the which is based on the power factor and actual energy consumption. So somebody has to or one has to maintain the power factor anyhow, which will decrease the reactive power flow over the transmission line and utility section. Okay, so this is the way by which the tariff is going to help in the implementation of demand side management, whereas BPL tariff, fixed rate tariff, subsidies in the electric bill is the hurdle in the implementation of demand side management. Next is the poor quality and reliability. Definitely someone is going to purchase a 5-star rating AC is there or refrigerator or any machines are there, but it is found that the voltage fluctuation is very high. It contained harmonic in the system. So it does not give the performance as it is expected. It is expected that the energy efficient machine give the conservation of energy, it will consume the less energy, but because of the multiple harmonics are there, because of the voltage fluctuations are there, it does not perform first, or it does not give the energy conservation, or it may lead to the failure in the system. That is the fault in the machines, failure of the motors, failure of the compressor for any ACs and refrigerators are there. So if the power quality also play a very important role in the implementation of demand side management. So nowadays we found that in some of the state, one more factor get added in the electric tariff is the harmony. If some of the industry or some particular industry producing more harmonic, they have to implement some penalty, or they have to, or the such type of industry has to install active filters in the factory itself. Okay, so power quality become a issue and barrier for the implementation of demand side management. We are thinking we are just uh, uh, lighting, we are just elaborating the things which will become a barrier over the demand side management implementation. Okay. Next is the small scale industry. So we found that in small scale industry there is no electrical engineer is going to appointed. Only some of the wiremen or skilled workers are there. They are going to do the maintenance work. So as they are not educated, as such type of people are not educated toward the demand side management, energy management, present scenario, as well as the power factor improvement, and their detailed calculations are there. Therefore, such small scale industry using some thumb rule, they will he will connect some capacitors are there, fixed capacitors are there. In the night time, the power factor will be unity, isn't it? And such small scale industry is not ready to invest the money in energy conservation, in the replacement of old machine by the new machines, isn't it? uh, Again, the say financial position is may not be good, or such type of industry does not has a ample quantity of funds for the purchasing energy efficient machineries are there. So small scale industry also one of the hurdle in the demand side management. Whereas in the big industry, number of electrical engineers, highly qualified engineers, experienced engineer are going to appointed, and definitely because of this education, because of the detailed calculation on power factor and all these things, such type of difficulty is not in the big industries. Funds are available, proper plannings are available, isn't it? So it found that the small scale sectors, small scale industries become a barrier in the demand side management. Next is the voluntary retirement of inefficient machineries are there. So nobody is ready to replace it existing machine only because of uh, it is not efficient way. Again, we will take the example of our home. If we have a three fans or four fans are there, we are not ready to replace existing working fan by the energy efficient fan, by the BLDC fan. Suppose I will give the suggestion is that you have a four fans are in your home, you replace it by the energy efficient fan. It is a BLDC fan which consumes so 28 watt or 30 watts are there. You will say no sir, it is still working, so why should I replace it? I will replace only when one of the fan or some fans are not working. Instead of repairing, I will replace it by the new fan. It's okay. But existing working machineries cannot be, the people are not ready to replace by the energy efficient. So it is called as a voluntary retirement. Voluntary retirement, uh, that even though the machine is working, we are going to replace only for the energy efficiency technology, for the energy conservation, or because of some findings from the energy auditor after conducting the energy audit in the premises. So a voluntary retirement, the people are not ready to do the voluntary retirement of inefficient machineries. So this is one of the issue or one of the barrier in the demand side implementation. So this is the things which is related to the all this one. Now by this way we will have ended the topic energy management and demand side management. If you have any doubt, we may discuss